In this problem, we're trying to figure out how many standard deviations away from the mean do all of the data values fall. So what we're going to do is a couple things. The first thing is that we have to figure out what are the mean and the standard deviation. And that's actually a really simple thing to do. We're just going to use our calculator. So let's go through how to do that. So you're going to take your calculator. The first thing you're going to do is press the Stat button. And then you're going to choose option number 1, which is Edit. Now, if you have something in your first list, and by the way, it is very important that you're putting this data into L1, which is list 1. So I have some data in here I need to clear out, so I'm going to arrow up, press clear, and then arrow back down. And that clears out everything in my first list. Not only is it important that we're putting all of our data into L1, but it's important that there is not data in any of your other lists as well. All right, so we're going to type in all of our numbers. So the first number was 123. So you're just going to press, type in the number, and then you go back and press enter to get you to the next line. The next number is 213, then 192, 234, 51, 139, 163, and 174. So when I press enter down here, it says L1 and then it has a 9 in parentheses. Even though we only have 8 numbers, it's because it's on the 9th blank. So that means we have 8 numbers typed in. Now we're going to press Stat again, arrow to the right so that calc is highlighted, and then we want option 1 variable stats. So it brings me to this screen. I'm just going to keep pressing enter until it brings me to the screen where all of my data is. So there are 2 things that are important that we need. The first thing is the mean, which is 161.125. And the second thing is the standard deviation. And remember that standard deviation, the one that we're using, is the sample standard deviation. So we're going to use the one that says SX. So that's like 57.6. So the next thing we're going to do now is we're going to take that information and we're going to label our normal curve. So our mean is 161.125. Just to make it easier on ourselves, I'm just going to say that it's 161.1. So let me write this over to the side. Our mean was 161.125, but I'm going to say that it's just 161.1. So we're not going to worry too much about the decimals. And then our standard deviation, again, it was a decimal. It was a long decimal. It was 57.56347428, but we're just going to say that it was 57.6, and that will be good enough for what we need to do. All right, so our mean goes in the middle, 161.1, and then going to the right, we're going to be adding our standard deviation of 57.6. So our next line, which is 1 standard deviation to the right, is 218.7. Going to the right again would be 276.3, and then all the way to the right, 3 standard deviations to the right is 333.9. Now we have to do the same thing going to the left. So now we're going to start with our mean and we're going to subtract 57.6. So the first standard deviation to the left of the mean would be 103.5, then 45.9, and then our last one is actually negative, which isn't quite right, but it doesn't mean we did anything wrong. It just means that we can't have values that are negative. So it just means that all the values that are in this last little section in between negative 11.7 and 45.9, it just means that we would only really be talking about the ones that are 0 or greater. All right, so now that we've done that, we can actually move on to what this problem is asking us. So what we need to do is we need to take a look at our data and we need to identify the highest and the lowest value in this list. So I'm going to start with the lowest because it just kind of stuck out to me. The lowest value is 51. So what we want to do is figure out which section on our normal curve does 51 belong. 51 would be in between 45.9 and 103.5. So I'm going to put an X in that section because that is where 51 would fall, and that's our lowest. We have to do the same thing with our highest value. So our highest value would be 234. So now I need to look at my normal curve and figure out where 234 would be. That is in between 218.7 and 276.3. So I'm going to put an X here. So now we're done with all of our work, but we need to interpret what it means. I'm going to put some labels on my normal curve just so that hopefully it kind of makes a little more sense. So remember that our middle is the mean, and then this is positive 1 standard deviations, 2 standard deviations, and 3 standard deviations. And then going to the left, it's 1 standard deviation, 2, and 3. So what I want you to notice is that this pink X, the farthest left that we could possibly go would be here because it's in between these two lines, and the highest it could possibly go is here where that other red line is. That makes sure that our highest and lowest numbers are definitely not going to get cut off. So I have to make sure I go to the left of the smallest and to the right of the biggest. And if you notice, both of these red lines are right above positive and negative 2 standard deviations. So 2 standard deviations to the left and to the right. So that means that all of my data fits within 2 standard deviations. So final answer is that all of our data falls within 2 standard deviations. So this problem is done. I just want to say one other thing, and that is if you happen to have a normal curve, and this will happen sometimes, not all the time. If you happen to have a normal curve where one of your x's is 2 standard deviations away, like this one was, so this was 2 standard deviations, and your other one is 3 standard deviations away, so maybe your other x is here, so that's 3 standard deviations away. So if they are not if it's not symmetric, they're not the same number of standard deviations away, you have to pick the larger one, because if I said my answer was 2, then my data would have to fall between here, and that's not quite right. So you have to, whatever the larger one is, that's your answer. So this would be 3 standard deviations if you have one where it's not the same.